When we talk about the fundamental interval, we are referring to the distance or the interval between the upper fixed point and the lower fixed point of a thermometer. Let me bring this means. Now, every thermometer has a upper fixed point and a lower fixed point. For this now, the lower fixed point of this thermometer is here and the upper fixed point is here. So, and we have three types of scales that we use in measuring temperature. And the first scale is the Fahrenheit scale. We have the Celsius scale and the Kelvin scale. Now, this is what we have represented here. The lower fixed point is the melting point of the substance. Then upper fixed point is the boiling point. We can see for degrees Celsius, the upper fixed point is 100 degrees. The lower fixed point is 0 degrees. And for Fahrenheit, the upper fixed point is 212. Then the lower fixed point is 32. For Kelvin, we have 373 and 273. So if you want to show the relationship between degree Celsius and Kelvin, so we're going to pick the two. So I have given us in the previous class that the code we are going to be using to understand is upper minus lower. The upper minus lower, that's 100 minus 0, then over C minus 0 equals to 373 minus 273, upper minus lower, over middle minus lower. This gives us 100 over C equals to 100 over K minus 273. This one cancels this. So we can say degree Celsius equals to Kelvin minus 273, or Kelvin equals to degree Celsius plus 273. If you are to find the equivalent of degree Celsius and you have been given a Kelvin parameter, you just take away 273 from the Kelvin that has been given. Let's say you are given something like 293. So as your Kelvin, and you are told to find the equivalent temperature on the Celsius scale, what you're going to do is you take away minus 273 from 293, and that will give us 20. That means the degree Celsius is 20 degrees Celsius. That temperature is 20 degrees Celsius. So and so for this. Let's look at the relationship between that of Fahrenheit, the relationship between degree Fahrenheit and Celsius, degree Celsius. So looking at the two, upper minus lower over middle minus lower equals to 212 minus 32, upper minus lower, over middle minus lower. And this gives us 100 over C equals to 180. This 180 difference is what we call the fundamental interval. You can be asked in a question that what is the fundamental interval of a Fahrenheit scale? The fundamental interval is the difference between the upper fixed point and the lower fixed point of that scale. And for this case, we have 180 for Fahrenheit scale. So we have 180 over F minus 32. Now cross multiply, we are having 180C equals to 100 into F minus 32. Divide both sides. Let's find makes it the subject of formula. We divide both sides by 180. 180 cancel 180. So we have C equals to, this cancels this. 10, 2 in 10, 5. 2 in 18, 9. So we have 5 over 9 into F minus 32. This is, so if you are given, okay, I will give you an example. So find, for degree Celsius, this is it. Now, let's make a subject formula from using mathematics now, the knowledge of mathematics. So we have 9C equals to 5 into F minus 32, divide both sides by 5. So we have F minus 32 equals to 9C over 5. Take 32 to this side. F will give us, degree Fahrenheit, gives us 9 over 5C plus 32. And this is the formula for finding Fahrenheit equivalent when given the Celsius. For example, example 1. Convert 20 degrees Celsius to Fahrenheit. Fahrenheit and Kelvin. So in this case, we are looking for the Fahrenheit and the Kelvin scale equivalent. So we have been given 20 degrees Celsius. So which of the formulas are we going to use? We're going to use this to find, so since we are given Celsius, so we put it here. Are you following? So look at this. You have to write your formula. 9 over 5 C plus 32. 9 over 5 times 20 plus 32. So we have 9 over 5. 5 goes here. 4. 9 times 4 is 36. So we can write it here. 36 plus 32. So the Fahrenheit scale is 68 degree Fahrenheit. So that means when you are measuring 20 degrees Celsius on Celsius scale, the equivalent is 68 degree Fahrenheit. Are we following? So to convert to Kelvin, we just use 27 C plus what? 273. And that gives us 20 plus 273, which will give us 293 Kelvin. Note, there is no degree Kelvin. It is Kelvin, just Kelvin. So let's now talk about the types of thermometer. Types of thermometer. We have about 5 types of thermometer, but let's start with the first one, which we call the liquid in glass thermometer. Why do we give it this name, liquid in glass thermometer? If you can see all these various types of thermometer that we have here, there is a particular liquid in it. So the liquid is either alcohol or mercury. So these are the major liquids that are used for liquid in glass. So this one too, this mercury. This mercury, it looks silvery, it has a silvery color. You can see. This is a stirrer, this is not a thermometer. So we can see from this end, this is the lowest point. So if this already faulty, this is a faulty thermometer. Let me see if I can find one that is showing color very well. Currently now we have the temperature to be around 30 something degree because of the heat. So if we apply it to this, the temperature will rise, the liquid in this glass will rise because of the change in what? In temperature. So the volume rises. So that's one of the physical properties of this liquid in glass thermometer. So the common liquids we use, used are alcohol and mercury. It measures temperature by measuring the change in the volume. The change in volume of a fixed mass of liquid due to a change in temperature. So one of the things we can see in liquid in glass, the temperature, when there is a change in temperature, what we discover is there will always be an increase or a decrease in the volume of the liquid. So in the change in temperature now. Now, we have talked about the two liquids that are used. Let's look at advantages. Why is alcohol used and why is mercury used? Which one has more advantage than the other? Advantage of mercury as a thermometric liquid. As a thermometric liquid. Number one advantage of mercury is that mercury does not wet glass. Mercury does not wet glass. We have discussed this under the two types of forces. We have coercive forces and adhesive forces. When we talk about coercion force, a coercion force is the force that occurs, the kind of force that exists between molecules of the same type. While adhesive forces are those forces that exist between molecules of what? Different type. If you look at the molecules of mercury, they have more coercive forces than adhesive forces. And that is the major reason you always see mercury not wetting glass. Unlike water, water has higher adhesive forces than coercive forces. So it will always stick to the walls of the glass. So mercury does not wet glass. Another thing is that mercury responds quickly to slight change in temperature. Slight change in temperature. Mercury, the liquid does not vaporize easily. The liquid does not vaporize easily. Why is this possible? Because mercury has a high boiling point, about 357 degrees Celsius, comparing it to alcohol of 78 degrees Celsius. Alcohol will have vaporized even before it gets to that temperature. But mercury can withstand high intense heat to about 357 before it starts vaporizing. So, and this is one of the reasons why we use the mercury is opaque. What we understand by opaque is opaque. Hence, it can be seen easily. Hence, it can be seen easily. Can be seen easily. If we use water as a thermometric liquid, water, we remember that one of the characteristics of water is it is a colorless, odorless, tasteless liquid. So being colorless, if it is inside one of these thermometers, you will be able to note the change in its volume, in the volume. But mercury is opaque. Alcohol can be, yeah, you can still see alcohol a bit, and you can add coloring to it to make it visible. But water is the worst thermometric. You can't use it because of some certain things. Then mercury has regular expansion. Mercury has regular expansion. Mercury has regular expansion. Let's look at the disadvantages. We also have disadvantages of mercury as a thermometric liquid. Thermometric liquid. Number one, mercury is very expensive. Mercury is expensive. It's expensive to get. Unlike alcohol, you can find alcohol anywhere. All these kiosks, they sell alcohol. But you cannot get mercury anyhow. Because of its what? Cost. The cost of getting it is high. Mercury cannot be used. Mercury cannot be used to measure very low temperature. Very low temperature. Why? Because its freezing point, the freezing point of mercury is minus 39 degrees Celsius. Minus 39 degrees Celsius. Okay, let's quickly look at the advantages of alcohol. Advantages of alcohol. Advantages of alcohol as a thermometric liquid. Advantages of alcohol as a thermometric liquid. Just as mercury, we have talked about mercury. We also have advantages of alcohol. So it is less expensive. Alcohol, it is less expensive than mercury. It is less expensive than mercury. It also has larger expansion. It has larger expansion on heating than mercury. On heating than mercury. Remember, I told you earlier on that mercury has regular expansion, but this has a larger expansion rate than mercury. And the rate is, it expands 6 times that of mercury. Alcohol expands 6 times. It expands 6 times that of mercury. We can also talk about its ability to be able to measure very low temperature. As we said, for under the disadvantages of mercury, it can only reach minus 39 degrees. But alcohol, it can measure very low temperature. Due to, because very low temperature, because its freezing point or melting point, freezing point is minus 115 degrees Celsius. Minus 115 degrees Celsius. So we also have a disadvantages of using mercury. Disadvantages of alcohol, as a thermometric liquid. Number one, alcohol wet glass, just as water does. Alcohol wet glass. Another thing we can say, it has an irregular expansion. That has a regular expansion, though it expands 6 times more than mercury, but its type of expansion is irregular. So it has an irregular expansion. Another thing we can see, that the disadvantage of mercury, of alcohol, is that it vaporizes. I've explained this before. It vaporizes easily. And it is not opaque, so it needs to be colored. That's another. It is not opaque. Therefore, we need to add some coloring agents to alcohol in order to be used as a thermometric liquid. Just as we have seen, this one is red in color. It's because a red coloring has been added to it. On a normal day, the color is almost off-white or looking like or colorless liquid. So, but we need to color it. So it is not opaque. It is not opaque. So it needs to be colored. Now, another disadvantage is alcohol has low boiling point. Of 78 degrees Celsius, while mercury has 357 degrees Celsius. Now, we have looked at these two thermometric liquids, but we need to know about water. Why? It can be asked in a question that, why is water not used as a thermometric liquid? It's a very common question. Let's look at it too. Why is water? We have water so abundant in nature. 75% of the earth is covered with water. So we have it in abundance. Why is it not used as a thermometric liquid? Why is water not used as a thermometric liquid? a thermometric liquid. Now, water has a very small range. Water has a very small range of expansion. That is, water freezes, it freezes at 0 degrees and boils at 100 degrees Celsius. Because of this low range of expansion, the small range of expansion, we don't use it. Then it does not expand uniformly. It does not expand. Water does not expand uniformly. What do we mean by this? Well, in the course of this class, we will be taught anomalous expansion of water. Water contracts between 0 degrees and 4 degrees Celsius. That is, it contracts. On the normal, it's supposed to continue expanding from minus something degrees Celsius, minus 30 degrees Celsius, continue to expand until it gets to 100. But along the line, once it's from minus to 0, it expands, and from 0 to 4, there is a decline, there is a contraction in water. Then from 4 degrees Celsius upwards, it continues expanding. So this is a kind of expansion that is not uniform. So it contracts between 0 degrees Celsius and 4 degrees Celsius, which will not give us a very good and accurate result. One third reason is that it wets glass. It wets glass due to the high adhesive force, which is greater than the cohesive force. It wets glass. It is colorless. It is colorless, thereby making it difficult, making the meniscus in the glass difficult to read. It is colorless, making the meniscus of the glass, meniscus in glass difficult to read. In glass, difficult to read. So we have different types of liquid in glass thermometer. We have one we call the clinical thermometer. Every one of us, we have been to the hospital at one point or the other during the time of coronavirus. Most places that we visit, we are always tested with the thermometer to check our temperature range, and that was what was majorly used. Well, and that type of thermometer that was used is a clinical thermometer. So, clinical thermometer is just a type of mercury in glass or liquid in glass. Of course, we know the make use of mercury in this clinical thermometer. A clinical thermometer It is a form of mercury in glass thermometer used in hospitals to measure temperature. of the human body. To measure temperature of the human body. For a normal body, for a normal person or normal healthy person, the temperature is always around 37 degrees Celsius. And it may rise to 41 degrees Celsius in cases of high fever. So the temperature range, we have to note the temperature range of the clinical thermometer is from 35 degrees Celsius to 43 degrees Celsius. So this is the range of a clinical thermometer. So if you want to draw this, so let me write it here. So we can see, so this we have a thick walled glass. This is the thick walled glass. Thick walled glass. There's something we call the constriction. This part we call it the constriction. Constriction. And there's the bulb. That's the bulb. And we have the Celsius scale here. This is the Celsius scale. Celsius scale. And there is the mercury column. So we have the mercury. This is more here. This is the meniscus of the mercury at 37 degrees Celsius. So this is a clinical thermometer. Clinical thermometer. Excuse me. Okay, let me write small notes about this clinical thermometer. It has a small bulb made of glass, of thin glass. The bulb as a narrow ball through which fine mercury thread moves. This makes it possible for small temperature changes to cause large changes in the length of mercury. The length of mercury column. Length of mercury column. Okay, I'll finish. Let's round up the class. So, because of the narrow ball, it makes this possible, and making the thermometer very sensitive. The thermometer very sensitive to changes in temperature. Okay, to temperature change. There is a part, the most prominent feature of the thermometer is the kink or constriction of ball, and this is near the bulb. The function of the kink is to allow the expanding mercury flow past it when the thermometer is placed in contact with the human body. Another type of liquid in glass thermometer is the 6 maximum and 6 minimum. Let's look at the kink. For the clinical thermometer, there is a constriction around there. There's a small constriction. This is the bulb part of the mercury. So another type is also the laboratory thermometer. The laboratory thermometer is quite different from the clinical thermometer too. But the major ones we talk about are the clinical thermometer and the 6 maximum and 6 minimum thermometer. So please subscribe to this channel for more videos. God bless you.